All right, section 1.3 is the slope and the rate of change. So I'll go over how to graph points, and then we'll look at how to find the slope from those points and the slope of a line that's already graphed. So the first thing I want you to do is graph these 2 points, A and B. So if we remember how to graph points, the first number inside the set of brackets is my x coordinate, and the second is my y. So it's how far I'm going to move from the origin or from the center, back 5 on my x-axis, that would be backwards this way, and down because it's -1. So -5 means back or to the left, and -1 for my y term means down. So I go back 1, 2, 3, 4, 5, and down 1, and I put a dot. So that's my first point that I have, and that's point A. My second point for point B is over at 3, 4. And again, 3 is on my along my x-axis, and 4 is along my y-axis, or along my vertical. So I go 3. Remember, they're both positive this time, so I'm going to go in the positive direction. Right 3, 1, 2, 3, and up 4, 1, 2, 3, 4. And that is my point B. Once I have 2 points, that's all I really need to draw a line. As long as I have 2 points, I can draw a line between those 2 points. I would probably put little arrows on them or whatever to show that the line keeps on going. But those are my 2 points, A and B. Now, how do I find the slope of this line? Well, the slope is actually what's called rise, and you might remember this, over run. So rise is how far it goes up from the bottom point. Run is how far it goes across. Now, it doesn't necessarily have to be the bottom point. It depends where you're starting from. But from here, I'm going up and to the right. Up and to the right means my slope is increasing, and it's positive. So I go up 1, 2, 3, 4, 5. If you count up 1, 2, 3, 4, 5, then I'm at the same height as this point over here. So I rise 5, and then I go over, or run, 1, 2, 3, 4, 5, 6, 7, 8. And notice that they're both in the positive direction. One is up 5, the other one is to the right 8. So that means that my slope is positive, and my rise is 5. My run is 8. So my slope ends up being positive 5 over 8. And that's my slope. And remember, this is positive, and it's increasing. And you can see that because my line goes up and it goes to the right, like upstairs. So positive increasing. Now let's look at the slope of JK. So JK, from this point to this point, I can count how much it rises. In this case, it actually falls, because you always read a graph from left to right. So it falls 1, 2, 3, 4, 5, 6 points, or 6 units it falls. And you can see it's negative because it goes down. From the left point to the right point, it goes down. Then I run to the right, 1, 2, and I'm running to the right, so it's kind of in a positive direction. So my slope ends up being, which is again my rise over my run. You can think of rise as being rise down, or like a fall. It could be fall over run kind of thing. So rise over run is -6 over 2. Notice that my 2 is positive, so that means my slope is going to stay negative. I could reduce this if you wanted to -3 over 1. Either one is acceptable. Sometimes people want them in reduced form though, so it's nice to know. Now notice this time that my graph is going down and sloping to the right. So it's negative slope, and it's decreasing because it goes down and to the right. So anytime you have a graph that's going down to the right, we have a negative slope, as we can see, and my graph is decreasing because it's going down. This graph is going from left to right, it's going up and increasing. So what happens if there's no graph? What happens if we're just given 2 points here? Well, you have to remember that my first term is my x, and my second one is my y. My first term is my x, second one is my y. It's very confusing for some people, because when you get to doing the rise over the run, what's on top? The rise. Well, that would make you think, oh, that's the first one. So that means that's my 1 and my 6. But it's not actually the case. What your rise is your y values, because it goes up and down, your vertical. And your vertical has to do with your y terms, which is the 3 and the 10. So for this one, my rise over my run, you can actually look at the points themselves. So from 3 to 10, is that going up? Yes. And is it going up by how many? Well, it's going up by 7. And it's going up, so it's positive. Next thing I do is I look at my 1 to my 6. So is that going up or to the right? Yeah, it's getting bigger. And how many is it getting bigger by? Well, 1 to 6 is 5. So my slope is actually 7 over 5. Now, what if I couldn't do it that way? I mean, that's a good way to do it if you can. That's typically sometimes how I would do them as well. Because you could always tell if it was negative or positive, and you could always tell what the value is. What you're actually doing there, though, is you're finding the distance between 3 and 10. So the way we do that is we say, well, that's 10 minus 3. That's the distance between 3 and 10. And I'm using my y values first because it's my rise. On the bottom, what's the difference between these two, 1 and 6? Well, I could do the same thing, 6 minus 1. And I get to the same answer, 7 over 5. But what did I actually do there? If I'm looking at a formula, then what I'm doing is I'm taking my second y term, which is denoted by y2, minus my first y term, which is denoted y1, and I'm subtracting them to figure out what the distance is between them, or the difference, right? So what I do for my x terms is I have my second x term here, my first x term here, and I do the same thing. X, take my second one, subtract off x, my first x term. So that's all those little numbers mean. It just means the first one and the second one. And that's basically your slope formula. Your slope is also sometimes called m. So I have my slope formula, which is also called m, or I could also just count the distance between each point. But you should be familiar with the slope formula as well, because it can help. Because if you look at number 2, it's a little more difficult, maybe it's more difficult, to see what the difference is between my first y term and my second y term. Maybe you're okay. Maybe you can see that from -2 up to 5 is a distance of 7, right? Maybe you can see that, but maybe you can't. So maybe it's a nice idea to use the slope formula. So I have y2, which is 5, minus my y1 term, which is -2. Be really careful with signs because they do matter. And you still have to put the minus. Now what happens when you have a minus negative? Right, it becomes a plus. So these minus negatives actually become a plus. So I get a 7 on the top. Now what about the bottom? Well, again, you could look at the -5 to 3 and think, oh, okay, that's still increasing, so it's going to be positive because it's going from -5 to 3. So it's increasing a distance of, and you might already see that it's 8, but if you don't, you can start with your second x term, which is this one here, subtract off your first x term, which is going to be, again, -5. So I have this problem here, or not problem, but I have the issue where I have two minus signs, which become plus. So 3 plus 5 is actually 8, and I get a slope of 7 over 8 for this one. So your slope might be negative, could be positive. You can use the slope formula, which is kind of nice. You take your second y term minus your first y term, over your second x term minus your first x term, which is the same as rise over run. So always know that it's rise over run, and know when to tell if the graph is sloping upward to the right, or if the slope is negative, it's down to the right. And it's negative and decreasing. All right, let's look at one last example here. So we're going to look at this graph of car sales for each month, January through December, so almost a full year. So how many months do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 full months, and I'm looking at the slope. And here's the number of cars. So this could be a used car lot. They're trying to get rid of all their cars because they're going out of business or something. So they start off with 11 cars, and they end off with 0 cars. right, to get rid of them all. And the first thing I say is, what is the slope? Well, can you tell me if the slope is negative or positive first? It's negative, right? Because it's decreasing, it's going down to the right. So it's going to be negative because we know it's decreasing. And it's negative. And what is the value of the slope? Well, I have to figure out what my rise over my run is. My rise over my run. Sometimes when you're given a graph, if you're given 2 points, the best thing to do is to count the distance between those 2 points. So the distance down and the distance across. Because if I start going like this for the rise over run, which you can do, you can count like this. Over, over. But if you notice, it starts getting a bit off here. My graph isn't actually going through these points at all. It works sort of for the first couple, but then it starts going off. So you can count the graph that way. But sometimes the best way to do it is to just look at the points that you're given and then count from the top point to the bottom point. So how far are we going down? Well, let's see. It's going a distance of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my rise, and it's going down to get to this point, is negative 11 over, now it's going in the positive direction. We already said there are 12 months, right? So negative 11 over 12. That's my slope. Negative 11 over 12. What does that mean? Well, the slope in this case means that it took 12 months to sell all 11 cars. Or he sold 11 cars in 12 months. Either way, it's a good way to write it. So the slope is my rise over my run, which was negative 11 because it went down to get to this point, over 12 to get to this point. So positive 12, negative 11. And the slope means that it took 12 months to sell all of his stock, all of his 11 cars. The last question is, how many cars did they start with? Well, you can see right up here that they started with 11 cars. Okay? And then you could see, you could even say, well, what about May? How many cars did they have in May? And you would go from May up to where your graph is, and you would say, oh, he had 7 cars in May. Or in August, how many did he have in August? Well, August they had maybe 4 or 5 cars, we're not entirely sure. But in sometime between July and August, they sold that car that was in between 5 and 4, or between July and September, I mean. So you can kind of look at the graph and what's called interpolate data, or figure out what data is in between. But you should know that the graph along this axis, which is your y-axis, where it cuts through, where it intersects up here, is how many cars they started with. And you should be able to tell from the graph, from a picture of a graph like this, and interpret information and answer questions. So if you get stuck, just go back, watch the video, understand what a positive slope is and what a negative slope is and what that means in terms of a real life situation.